Well, good afternoon, Physics 30s. Okay, we're moving on with Unit 3 on electromagnetism. Of course, this work booklet is available on Google Classroom. It's under the Materials tab. Or you can let me know and I can get some ready and you can come pick them up. I have them for the rest of the course, okay? What we're going to do is we're going to start with magnetism. So the fundamental law of magnetism is that there are two magnetic poles. There's a north magnetic pole and a south magnetic pole. Opposite poles attract and like poles repel. This is the fundamental law of magnetism. Magnetic fields. We define them with a capital B with an arrow over top. It's a vector field. Magnetic force, F subscript M, is a distant force, kind of like the force due to gravity and the electric force. Its influence on other objects is best understood using fields. Just like we have a gravitational field and an electric field, we can study a magnetic field. Direction of the magnetic field is the direction that the north part of a test compass points, and it's the same direction as the net magnetic force vector on a north test particle. Just like we used a positive test particle to find the direction of an electric field. Just like we used a small mass to test the gravitational field direction. Okay? The magnitude is shown by the density of the field lines, how close they are together, and the density of those magnetic field lines is called magnetic flux. Right, for a bar magnet sitting right here, North Pole, South Pole. Notice the magnetic field points in the direction that a compass, North Pole of a compass, is pointing, and so comes out of the North Pole and loops around and back into the South Pole. Highest flux is at the ends of the magnet, so at the North Pole here and the South Pole here. And the magnetic field goes from north to south outside of the magnet. For two bar magnets, like poles, of course we're going to repel each other, and opposite poles will attract each other. A quick little visual of this, why not? And so what I'll do is I'll use a piece of paper. I'll start off with just one bar magnet, such as this one here, and I will bring a compass around. Notice the compass here does have, on the end of it, it has a north pole. It's kind of hard to see, it's a little N on the end here, and it's pointing away from this north pole. So the field's coming out this way. And so at this point, I know that the field's going this direction. You can see now that it's moved up this way, it's actually going up this direction. And then as I bring it around, okay, kind of moving up this direction, so kind of like that. And then, of course, as long we go along here, okay, and it's moving along in this direction here, and you can see, you can kind of get the idea that it's going to eventually loop around, okay? And on this end here, I'll just bring it over to show that North Pole again is pointing that direction, and then we can continue in the process here, right? Bring it all the way back around, and then you can see it's a three-dimensional thing as well, so I can set this over top, and it should be pointing, of course, from north to south since it's outside of the magnet. To visualize the field, it can be done by using something like iron filings, right? Iron filings are affected by a magnet, and so I'll go ahead and sprinkle some iron filings just a little bit around to get an idea of what the field will look like. There we go, season it up a little bit. Okay, wonderful. Oops, well, accidents do happen. All right, so I'm going to go ahead and kind of shake it out a little bit there, and then kind of tap it a little bit and kind of get an idea of what the field sort of looks like. It does loop around a little bit. Okay, notice it does concentrate right on those poles. That's where really most of it's starting to accumulate once it's spread out a little bit from the center. Okay, whoa, wild. All right, I'll introduce another pole here, and we'll take a look at two like poles to start, and then we'll just do two unlike poles. Here's two north poles, and so the field between these two. Okay, you notice it's kind of a field that tries to push apart there. Okay, and so the field lines kind of start to push away from each other. Okay, and if I go ahead and reverse one of these, now we have unlike poles, so north and south. And you can see what happens between these two. It pulls together, okay? And of course, if I bring them in close enough proximity, the two magnets will stick together. Okay? All right, wonderful. I'll stop it right there and then continue right along in a moment, okay?